with the pictures and videos, but I'll talk my way through it, and hopefully we can upload the full presentation at some stage. So my topic of talking today was just talking from a prosthetics point of view and talking about what's new in componentry. So if you can flick a slide, Barbie, please. So I was just going to, I had amended a presentation I've made lots of times, but just talking about the history of prosthetics. They've been around for a long time, and you'll see a picture there of one of the first known prosthetic devices, going back about 3,000 years ago from Egypt. And just one more click, please, Barbie. And for a very long time, the materials of wood and leather didn't change very much. So you'll see those shots from a wartime shot, and they're exactly the same materials that were used in that earlier shot. Can you click that again, please, Barbie? I forgot there's lots of... But my role as a prosthetist changed very much in the last few years, in the fact that blacksmiths and armourers were the first prosthetists in early times and war times. We've evolved we are now tertiary qualified allied health professionals, and now we're certified orthotist prosthetists through the Australian Orthotic Prosthetic Association, or AOPA, as we know. Now, moving to that next slide, please, Barbie. And actually click a few more times we'll just get the those points out. So obviously a prosthesis, a modular prosthesis these days, which has the custom-made socket that the prosthetist is responsible for manufacturing, and then modular components below that. So anybody that's worked with a prosthesis will be familiar with those basic components of a that's an above knee prosthesis. So there's obviously a knee component in that, and connective componentry attaching the socket to the knee, and then a pylon down to a foot. So can you click that again, please, Barbie? Oh, that's interesting. That's not even the right... It's
not what you wanted?
I think there'll be another part come up, but that's okay.
Go back or go forward?
I had some more slides with the... No, that's... Just go forward once more. I think there'll be more things pop out with one more click, maybe.
I see Gemma's just come back. No? Okay.
Yep, that's great. That slide I'll just talk to that slide now. I did have a breakdown slide for each of these topics. So for a long time, the socket materials have been very static in prosthetics. We've used traditional sockets with peel-out liners and fiberglass composite sockets, and even today at Fiona Stanley, our basic interim prostheses still utilise these materials. However, there's lots of different materials coming into use, and a lot of them around flexibility, which allows us to increase comfort while maintaining control with the prosthesis. So flexible plastics and higher grade composites such as carbon fibre allow us to achieve those goals. But there's even been further advancements in terms of flexible resins, but also the incorporation of padding, so silicone or gel padding within sockets, which has made a real difference to being able to create sockets that fit very intimately, provide great control of the prosthesis, however, providing both flexibility or padding to appropriate areas to achieve comfort and allow a prosthetic user to wear for longer periods of time. The future in this area will undoubtedly be 3D printing. There is 3D printing happening in prosthetic practice around the world, but almost exclusively printing hard sockets, often the diagnostic or check sockets that are the first stage fittings, and then manufacturers reverting to traditional composites. However, as material technology both improves, but more importantly becomes cheaper. We'll be actually able to 3D print multi-durometer sockets with stiff, strong parts for support and control, and softer, flexible parts for comfort. This is an area that's developing quite fast, but not to the point where we're using it as yet. The other really important part of materials that have been progressing in the last few years is socket interface, where the traditional peelite laminate sockets used cotton and wool socks against the skin. Over the last decade or so, we have moved in definitive prosthetics very much to using silicone and gel skin interfaces. At Fiona Stanley, our interim prostheses often still use the older-fashioned sock peelite fit, but that also is a bit around being able to be adjustable for an interim prosthesis where we need to rapidly change the socket fit to fit the rapidly decreasing stump volume. However, we are increasingly using gel and silicone liners. A good example of this is in transfemoral interim limbs, where we're using silicone seal-in liners, which means that we have a silicone interface that grips to the stump, and the silicone stays in the socket through a suction mechanism with a one-way valve in the socket, which means that we don't need to have belts and straps, but we can also achieve excellent suspension, so the prosthesis is not moving or twisting on the amputee, as well as having the benefits of the silicone interface against the skin, which can reduce shear, increase comfort. And there's several other gel liners that are commonly used. So either TPE gels, which are thermoplastic elastomers, for softer, or it's a softer gel which can reduce shear forces and often used for heavy scarring or very sensitive skin, or urethane liners, which are used for higher activity clients. The urethane liners are quite specialised in the fact that they need a total surface bearing socket to utilise the flow properties of urethane to really get amazing control through a hydrostatic fitting socket, yet achieving great looking after the skin through a really gentle skin interface. Moving on to prosthetic componentry. Now, obviously, the main prosthetic components of prosthetic legs are feet and knees. So it's just starting off with feet. Traditionally, prosthetic feet consisted of a cushion at the heel. So when you accepted weight onto the prosthesis, there was some cushioning and it wasn't too hard. And then a solid keel to give you stability as you stepped onto it. And this type of foot was called a satch foot, a solid ankle cushion heel. Again, we still use these feet in interim prostheses, but as there are a larger variety of components becoming available, the costs of these components are coming down, but also funding schemes such as the NDIS give amputees a broader choice of components. The breadth of feet available are increasing. The feet can be broadly broken down into two categories: a dynamic foot, which provides movement through spring and through energy storing, and multi-axial feet, which provide movement through absorbing energy or damping. So you might think either a carbon fiber spring is the most classic example of a dynamic foot, and a rubber bumpered multi-axial foot, the best example of a true multi-axial foot. Now, neither of these designs are particularly new. There's been dynamic and multi-axial feet around for many decades. However, with the advent of carbon fibre feet, again over the last few decades, this technology has really improved and gone forward, and the latest feet that are really achieving some amazing functional aims combine the two. And I show it had a fantastic video of a particular foot that combines several pivot points to provide multi-axial movement through mid-stance, so providing great adaptation to terrain, but then at the end range of those movements, then loading up some carbon springs to provide some dynamic response and some energy return to walking. So getting the benefits of a multi-axial foot and combining with the benefits of a dynamic foot also to go with that. There are also a growing number of specific componentry designed around recreational vocational needs. Over the year, I've made lots of specific prostheses with attachments for a rowing arm, a bike riding arm, an industrial arm, to with specific tools in mind. But probably the most widely spread and the most functional development in this area is the advent of waterproof componentry. Once upon a time, prostheses were waterproof in their very simplest form, often with the exoskeletal fiberglass shanks, so no metal components, and satch feet. However, now with the advent of titanium componentry and stainless steel fastening, there's a huge range of modular componentry that is waterproof, and also many dynamic and multi-axial feet that are waterproof, as well as knee components as well, meaning that we can make prostheses that can be either used in the shower or in recreational setting in wet environments, which is it's a really great thing, especially with the advent of funding within the NDIS that allows funding for amputees to have prostheses for different purposes and to achieve their goals in life. I briefly touched on prosthetic knees. Prosthetic knees are a mechanical device designed to allow knee flexion and extension during swing phase and stability during stance phase. Traditionally, this has meant that they were a mechanical device that, under a certain set of circumstances, would provide each of those different functions, either be it in swing or in stance. However, this always led to the problem that there was always a circumstance where the function needed during swing of free motion could appear when you didn't want it to during stance, and we have falls. And teaching transfemoral amputees, it was a reality of that it's probably not if, it'll be when you have a fall. Microprocessor knees have somewhat changed that game in terms of providing an amazing amount of stability, checking up to 50 times a second of what the amputee is doing and what they're needing in terms of stance stability or freedom during swing, therefore allowing an amputee to not be worried about falling and have a bit more confidence about striding out and becoming very much more functional. The obvious downside of microprocessor knees is the extreme cost that they come with. And that is Still a problem with microprocessor knees being equivalent in price to cars, both with luxury and budget models. But once again, this is an area that in coming years, those costs will continue to fall as the technology improves. Manufacturing, meaning motors will become smaller, batteries smaller and lighter, meaning that these prosthetic components will become more accessible and more functional. The symbiotic control of prostheses was a brief mention with regards to mainly upper limb prostheses, where in historical times, upper limb prostheses were body powered, controlled by cables attached to the contralateral side, usually meaning that you're operating it through body movement. In recent years, there have been electric prostheses. Sorry, hang on, I just went a bit dark there. That's okay, I'm back. Electric prostheses were controlled through myoelectric control, meaning that muscle contraction, just 1 second, sorry.
Is still okay, Brendan? I don't know if you want to turn your video off so we can hear you okay.
That's okay. Sorry, I just had someone turn all my lights off on me. So myoelectric prostheses were just 1 second.
Having all sorts of fun and games here today.
Sorry, no, a teenage son with a phone just walked through and turned lights and did all sorts of things then.
Okay.
So myoelectric prostheses being controlled by muscle contraction. However, these were incredibly clunky, cumbersome devices, and as the primary focus of an upper limb prosthesis is fine motor control, didn't do that very well. However, with the advent of TMR, as Ian Wilson touched on a couple of weeks ago, is plugging individual nerves into functional muscles and thereby being able to have individual switches. And this is an area that will really come on in future. And very briefly, osseointegration is a huge advance within the prosthetic world in terms of the prosthetic socket we were talking about, which the job of a prosthetic socket is obviously to attach the prosthesis to a limb to achieve comfort and stability, and osseointegration removes both of those issues by achieving perfect stability and, all going well from the osseointegration site, perfect comfort. Obviously, there's the issues surrounding the stoma that the osseointegration implant is extruding, and there are some issues with infection, but it will be an area of prosthetics that will grow and improve, and game changer for some amputees. And I think I'm up to time there, so I'll stop rambling on. Hopefully I will be able to provide the up-to-date presentation at some stage, but happy to take some questions with Gemma now.
Lovely, thanks Brendan very much. If anyone's got a burning question for Brendan, you could unmute or put it in the chat. And I'm going to stop sharing my screen, Gemma, so you can go back to where you were.
Could you tell me which slide you got up to? So sorry, I don't know what happened then.
Brendan, I might get you to mute, and I will just go and have a look at the PowerPoint. I think you just started on high level mobility, Gemma.
Okay, great.
Hang on a minute. No, the return to running slide is where you were.
Oh, okay. Nearly done then.
Yep.
Nearly got through.